For our next talk, we'll have Enrique Garcia with continuous integration with Lua.
Okay. Thank you everyone for coming. My name is Enrique, as he said, and I maintain several reasonably popular open source Lua modules. They are all in GitHub, and you can see them on my website. Sorry. Now, yes. On my GitHub account, which is Kikito, K-I-K-I-T-O, you can find all of them, including middle class, which is the one I recommend for making classes with Lua. But there are many others. And this presentation has several links to several documents and libraries. You can find it here. The slides are here, so you don't have to write every single link down. I'm going to put this at the end too, so you don't have to even write this down right now. So let's start with the talk itself. I have divided it into 3 parts. The first one is definitions, mostly. So it works for any language, not just Lua. Then I'm going on into the how part, how I do continuous integration with Lua. And finally, there is a small conclusion. So let's start with the what and the why. Continuous integration. I'm going to use the following definition. Continuous integration, for the purpose of this talk, means some automated and frequent checks done on code, normally on a repo somewhere. So repeating or taking each word individually, automated means that they are done by machines by themselves, without any human having to say, run the tests now. Frequent means that they happen quite often, usually, or ideally several times per day. Usually every time anyone makes a commit in the repo. And finally, the checks themselves can be quite different. People seem to think about checks in continuous integration as specs, which is basically pieces of code that check that your real code is behaving like you think it should. We will see later on that this is not the only thing that you can do on continuous integration, but it's true that it's the most popular thing to do and probably the most important thing to do too. That's basically the definition. Now, the why. I have to make a confession here first before I delve into this, which is that this is my first time in FOSDEM, and I committed a mistake. I didn't investigate the level of the audience of this talk, so I made it quite basic. But probably most of you here already know why we should use continuous integration, so I apologize in advance. You will probably already know this stuff. For those of you who don't know what it is or don't know what a spec is, you just say, okay, and that's fine. So when people are presented with this thing, like you have to do continuous integration and write tests and configure machines so they run those tests for you, they ask, but that takes a lot of time. That takes a lot of effort. I have to learn lots of new things to do this thing that you are telling me to do. Why should I do this? And the answer I give them is twofold. I have 2 ways of answering this. The first one is a story, a small story, based on this graph. This represents 2 parallel universes. The one in the red is a common project which started, a software development project which started, and people didn't know anything about writing tests or continuous integration or anything. Just they started writing code and maybe putting it on a test server and making some manual tests and then moving to production. Over time, I'm not saying how much time or how much effort, because it really depends on the project, but over time, the cost of adding changes to that source code, either new features or removing features or fixing bugs, increases. Why? Well, for several reasons. First of all, the people who are working on this project may leave and their knowledge goes with them. New people arrive and they start making changes that they don't know break things, like this weird edge case that they forget to check when they make the code, things like that. Little by little, every new change increases the cost. This happens on every project. This is not something I'm inventing here. Now, on the other universe, this same team of people start by investing some effort on putting up some continuous integration system. And at the beginning, it's true that it takes more time and it takes more effort, because they have to configure these servers, they have to learn how to write these tests that they didn't know how to maybe before. But this cost of learning how to write tests usually can be spread amongst several projects, so it's not such a big deal. But it's true that at the beginning there is a bump in the effort. Then, however, as time goes on, the cost of making new changes in the code, which is like the silent killer of software in general, is lower. Why? Because if someone leaves, like I said before, their knowledge about this weird edge case that has to be tested is done by the machine automatically, even if that people is gone already. When a new person arrives, they commit some change and the machine tells them, hey, there is an error here, you have to check this down. So this basically gives you a foundation or a safety net against changes in time. All the projects I have seen are successful not because the initial months of the project, but because what has happened years after the initial commit or the initial effort. So if you have to spend 1 week or 2 weeks configuring and learning this stuff, I really recommend this. So as I said, the other way to look at this is like a safety structure. If your project is a mine, this is, for example, a photo of a salt mine in the United States. Continuous integration is these walled structures on the sides of the tunnels that make sure that your project doesn't crumble when there is a change, which is basically an earthquake of some sorts in your projects. So if you already knew this, I'm sorry, but it's also good to rehearse if you have to convince someone else about this. Now, I'm going to go into how I do tests and continuous integration with Lua. I don't have a lot of time, so I'm going to explain my particular implementation. So I'm using several tools. My projects are all hosted on GitHub, and the continuous integration main server is Travis, and I use several other tools. Not all of them have nice icons, so I'm only showing these 3. You can probably swap one or several of these by other tools. This is my solution, but yours will probably be a bit different. Okay, so you have to adapt it. But it's simple, you will see. The first thing you have to do is setting up what I call the environment. In my case, the environment means that I need some way to check things in several versions of Lua. The ones I like are the vanilla ones, 5.1, .2, and .3, and Luajit, .0 and .1. You might need some special Lua version that you want to check. How do I run tests on all of these things? Well, I'm using Travis. And if you're using Travis, you need something called .travis.yml. I'm going to call it travis.yml from now on. This is a file that you put on your repo. And it basically tells Travis how to do those checks I told you about at the beginning. Travis supports several languages from out of the box. You have to do very little to set up this environment for these languages. For example, in Ruby, you just have to say, hey, my language, this is the travis.yml. You say, my language is Ruby, and I want to have my test in all these versions of Ruby. And Travis takes care of everything else. It installs each version, and it passes all the tests, and it's a bit like magic, very easy to set up. Lua doesn't have this. It's not supported by Travis by default, so you have to work a bit more to make it work. So what most people end up doing is something like this. They use whatever language they want at the beginning. It doesn't really matter because you are going to install everything by hand. And then you use the env namespace that you are seeing there, which basically says, run one set of tests with these environment variables. In this case, just one environment variable called Lua. So run them once with Lua equals to Lua.5.1, another one Lua 5.2, etc. And then before, sometime later in the test, they do something like what you see at the bottom. Before install, run this shell file which installs the version of Lua I want and the version of Lua rocks that I want. And this, it's mostly fine. I only have a problem with the last line here. Why? Because that install lua.sh file looks something like this. It's a shell file which is usually like several hundred lines of code that you have to put in your repo. It's also shell script, which is one of my least favorite languages to work on. The only one I hate more is Vim script, probably. And I don't want to have to maintain this stuff only to install Lua and Lua rocks. So when I compare it to what I have to do to work with Ruby, I'm not happy. Fortunately, there is a solution, and that solution comes from a weird place. It comes from Python. There is this project called HereRocks, and again, all these links, you can find them on the presentations which are online, and you will find the link at the end. This project is done in Python, and it basically allows you to install Lua and Lua rocks with one single command in whatever folder you want, which is great. So all the rocks you install later on are inside a folder contained. So if you want to test locally in your computer several versions of Lua, you can use this thing too, and it's very easy. So how do you use HereRocks with Travis? Well, I'm not inventing anything here. You can see how to do it on the README of HereRocks, but basically you have to do this. You set up the env variables just like before, but then the install, it's only 3 lines. You also have to say that your language is Python only because you want to have pip, which is the one you use to install HereRocks, which is the real thing that you want. And then you install Lua with that. And that's all the code that you need. You don't need all those hundreds of lines of shell script anymore, which is great. That's what I wanted. So my environment is set up. The next thing is specs. Some people call specs automated tests. I don't like to call them like that because it's a very generic term. Performance tests are also automated tests, for example. So what I call specs are basically the code that checks that your code behaves like it should, like I said before. The functionality of your code, I mean. For this, I use this library, Busted, from Olivine Labs. It has the way it works is the following. You have a library. I'm going to create a very simple library here. It just returns a table with a function which adds two numbers. And I can test it like this with Busted. Busted basically provides me with several global variables. One of them is called a describe. There is another one called it. And it also changes the way assert behaves. So it changes several things on the global scope. That's one of the things I don't like about Busted. And it's not the only one. At the end, if you want to ask me about what I don't like about Busted, you can. But it's the one I use because I think it's the least bad one out there. You can install it in your computer and run tests. For example, here I'm running the test of my library, middle class, the one I recommend for doing classes. And if everything goes okay, you will see a lot of green dots like this. And if one of your tests fails, you will see something like this. One red dot instead of one green dot, and then one message saying what happened. Like I was expecting one string here and I found another string, something like that. Now, installing Busted in Travis is quite easy. You just use the install namespace here, and you tell Lua Rocks, which is already set up on the environment phase, to install Busted. And then you execute it with Busted. I like to add the verbose option because it gives you more information when there is an error, and otherwise it just shuts us up, so it's great. And another interesting thing is once you have this, Travis on its website already shows you a report saying, okay, you gave me 5 jobs to do, one with each environment variable, for Lua 5.1, Lua 5.2, etc. It shows you here the result, everything is green. It's also integrated with GitHub. So in this case, I made a pull request, and it turned yellow. So this means that Travis is running the tests now. After a while, like 1 minute maybe, it turns either red, meaning that something has failed, or green, which is everything is fine. Notice also that the commits at the top are marked with a red thingy or a green thingy if they are breaking the build, that's the name usually used, or not. And also on the pull request section, you can see the pull requests that are breaking your tests or not, with the green thingy next to them.
Can I ask a quick question?
Sure.
Is this automatic, or you need to set up a webhook?
In the case of Travis, it's automatic, at least if you log into Travis with GitHub, like I did. Because in that case, you give it permissions to make changes on your repos.
But is it automatic as soon as you do a pull request? Then
Yes.
you can run this?
Yes, that's the idea. It has to be automatic. If you have to tell it to do it, you are not doing it correctly. But it's true that you then have to enable it on each particular repo that you want. So Travis presents you with a list of repos, and you say, hey, test this once. And then that's all you have to do. It's like 2 minutes, really easy. So as I was telling you before, all this gives you like security. If someone sends you a pull request, automatically he will see this, like, hey, your pull request is red. Something is not quite okay with what you sent me. You don't even have to look at it. The machines tell him already. So this is clearly less effort, less things you have to maintain. It also happens in your own projects. Like sometimes I do pull requests to myself just to make sure that all the tests pass. And then I accept them when they're green. It's so easy that it's worth it to do it that way. I'm going to talk about another kind of test that you can do now, coverage. Coverage is a number. It's not really a set of tests. When you run the specs on your code, coverage is the amount of lines of your library that have been run by those specs or those tests. So in this case, I use coveralls, and it gives me what it does is present in coverage in a very human-friendly way. The view I like the most is this one. This is my main file of middle class, and there are 3 colors. These are the lines of code of that file, and there are 3 colors. The white ones, or whitish ones, are not important lines, like end at the end of a function or else on an if. They have syntactic value, but not semantic value. The rest are interesting. The green ones have a number next to them. This is telling me how many times each line has been executed while running the specs. The red one over there is one which is not run at all while my tests run. So basically this means I'm missing a test somewhere. I should add a test that makes sure this if-else is at least executed once. This is still happening on my code. I plan to fix it after FOSDEM. But if you want to send me a pull request, you can. And the tests will run automatically and everything, and you will see all this if you want. Coveralls also integrates with GitHub. So instead of 2 checks, The first two here are from Travis, and the last one is from Coveralls. It's saying, hey, everything is okay. The coverage hasn't gone down after this pull request. An important thing to mention is that Coveralls itself is a presentation tool. It doesn't really calculate the coverage. Sorry. You have to pass it some kind of JSON, and then it does its thing. It presents. So how do you do that? You use something called Lua.cov, which is the standard coverage tool from Lua, but Coveralls doesn't understand the output format of this thing. So you have to pass it through another project called Lua Coveralls, which basically translates and sends it to the server of Coveralls. So setting this up is actually quite easy. Again, you can install both of these things with Lua Rocks. So you put it on the install section of Travis. And then you, at the end, if everything has gone all right, because if you have a failure, probably your coverage doesn't really matter. If everything was okay, then you send the coverage results to coveralls.io. One interesting thing about this, one case of synergy with the tools I use, is that Busted, which is the tool for the specs, already supports Lua.cov. If you add the coverage option when you run it, it already generates the file with the things that the other tool needs. So this is great. And also I want to notice that at the end, I had to add this special parameter because I'm using here rocks to install the stuff, and it's a bit non-standard. So you have to tell it, hey, don't look at the here rocks part of the coverage. The last thing I want to talk about is static analysis. And for this, the best tool I know for Lua is LuaCheck by Peter Menlichenko. I hope I said that all right. This basically is a tool that you can run independently of the others, but I wanted to talk about it at the end. It doesn't need to run your code. It just needs to read it, and then it gets lots of useful warnings and errors from it. This is how you run it locally. And it tells you, for example, you are not using this variable that you declared before, things like that. But the one that will probably interest you the most is that it detects global variable declarations. So if by mistake you forget to put a local somewhere, it will tell you. And it will be an error, not a warning. So this is very good to make it automated. It is so good to make it automatic that it's possible to hook up LuaCheck with your editor. So every time you save a file, it tells you already, hey, you're declaring global variables here, so pay attention. And there are other things that you can check, but that's the most interesting one. Setting it up in Travis is quite easy too, with Lua Rocks. And then, I said it, I wanted to say at the end, it's also integrated with Busted, because as I told you before, Busted declares some global variables, like describe or it. LuaCheck has a Busted section option that basically makes it ignore those global variables. Otherwise, it will tell you something like, hey, I don't know what this describe thing that you're telling me about is, and it will give you an error. So everything is integrated, and that's why I like it. All together now, this is how you set up the environment, so installing Lua and Lua Rocks, several versions of them. And this is basically running specs, running coverage, and running static analysis of your code. Overall, it's like 20 lines of code, and you do a lot of stuff. So it's totally worth it. And I'm running out of time, so I'm going to skip over this section, but you can ask me in the question sections if you want. These are things that I don't do in my code, but I have investigated a bit. C extensions. If you have questions about that, ask me after the presentation. So I'm going to skip. Working with Microsoft Windows. If you have questions about that, ask me later, and I will tell you. But the conclusion now. We have seen what it is, why should we use it, and how to do it with Lua. One thing that I should stress is that I never put here if we should do it, because we should do it. Unless we're doing something like a hackathon of one weekend, code that we are doing and then throwing away, or one a game jam of 1 week or something like that. In that case, you can skip them because the initial bump is going to probably make it not worth it. But in any other case, any serious project that takes more than 1 month to develop, you should do this. Otherwise, that's why you'll fail. And that's all I have. Thank you. So if you have questions or if you want to copy the link here, you can do it now. Like anyone wants to ask about how to do it on Windows. I only use it for playing games, but some people use it for other stuff. I see that you don't use Windows. Yes, this is FOSDEM, of course.
Just for playing.
Yeah. And let me go quickly through the C extensions part, because probably that will interest you anyway. So going back here, this is what you will get on Google Images if you look for C extensions. This is quite weird. It's a musical instrument called counterbass, I think, and it has several strings. One of them is called the C string because of the note that it plays. In some cases, they want to make it longer so it plays more notes. So they add a C extension to the instrument, which is quite nice. But in Lua, it means that you are doing some library that interacts with maybe a database or something like that, and you need C. In that case, Lua Rocks make is your friend. You will probably need to do a rock that does something like this. In your repo, you will have a rock spec called usually SCM something, like your name, SCM rock spec. And it will have a build command saying, hey, you should run make, and you should do this and do that, and a bunch of C stuff that I'm not really interested on because my libraries are pure Lua normally. So another interesting thing that you should know is that in order to install all those compilers and make and stuff that you have to install to make C work, Travis already supports some of that stuff. You set the language to C, and then there is an add-ons apt packages section that allows you to install Clang and CMake and everything faster than if you told it to do apt get install whatever package you need. So use this instead of manually running apt install every time because it's faster. And at the end, you should run at some point Lua Rocks make to run the other thing with the SCM rock spec and everything. And that's it. Oh yeah, another important thing is that there are examples of Travis YML doing this. One that I found is on the Torch project. The Travis YML already does this stuff, like installing compilers and creating the C extension and everything, so you can look at it and see how they do it, because I didn't do it myself. That's it. This is Windows, no. Okay.
Let's thank you once again.
Thank you very much.